Hello all. Right now I want to talk to you about IV curves. This is a lot of this is something you already know. This is not something particularly difficult. The only new stuff over here is going to be a curve as a visual way of representing the relationship between the current and the voltage, and some of the LED curves, because the best way to understand the LED and how it works is, to look at its IV curve. So first, let's talk about IV curves of the things we do know. And the first thing that comes to mind is a resistor. So this is going to be the IV of our resistor, IV curve. So IV curve is really a relationship between the voltage and the current. And we already know that the relationship between voltage and current for the resistor is Ohm's law. So in other words, our voltage is proportional to our current, directly proportional. And resistance is inversely proportional. But here's the thing, guys. A resistor, a resistance of a resistor is not a changeable value. So in other words, resistance of a resistor is constant. In that case, when we rewrite our Ohm's law, and this is V I equals V over R, we can rewrite it like this, as I equals parentheses 1 over R times V. Now I know this looks exactly the same as that expression, but if you look at it, it's also an equation of the line. If you guys remember this one from your algebra class, we have exactly the same situation now, where your y is your I, your x is your v, and a, that number, right? That a number generally means it has to be a constant, right? That is just 1 over r. So now I can go ahead and draw my equation of my line. And let's see. So I'm going to go ahead and draw my line. So here's a perfectly good line. Now we know that the slope of this line is going to be 1 over r, right? So slope is 1 over r. And that's basically it. As you increase voltage, you increase current. We know that. And the slope is 1 over r. Well, that was pretty easy. So let's look at some other stuff. Well, the other element we know is the battery. The question is, can we do an IV curve for the battery? Here's my battery symbol. Of course we can. It's even simpler than the equation of the line. So the first thing we need to remember is that battery can have any current. So our current could be any current, really. So our current is not bound by anything. That means there is no kind of boundary that it has to cross and cannot cross. No boundary. Now what about voltage? Well, voltage actually does have a boundary. In fact, it's just one value. Think about it. When you get a 1.5 volt battery, it's supposed to have 1.5 volts and no other value. Now, of course, considering how they're made, some could have 1.4 and some could have 1.6, but that's not the point. Whichever the value your battery has, that's the value that your battery is going to keep. Now, of course, I know that the batteries discharge and eventually they get less voltage, but we're not talking about long term here. We're talking about very, very short term, 1 second after the other. So if a second ago your battery was 1.5, guess what? 3 seconds later, it still better be 1.5. So let's go ahead and draw that line. So that means that my line can go anywhere up, and it should stay at the same value of voltage. So that means it's a straight up vertical line. So there we go. So that means my voltage is going to be, let's pretend this is 1.5. So this is 1.5 volts, right? The voltage does not change. The current, as you can see, I can have 2 milliamps here, and I can have 100 amps here, and I'm still going to have the same voltage. Now, of course, that is the behavior of the ideal battery. Real 1.5 will probably get discharged way before it can give you 100 amps. But theoretically, that's what it should look like. And now, let's look at the VI curve of an LED. So here's my LED symbol. So this curve is nowhere near as nice. In fact, it's so not nice that I'm not going to give you a mathematical expression for it. But ultimately, there is no need to give a mathematical expression for it, because we can get all the information we want from a graph. So this is what I'm going to do first. So here's the graph of my LED. Now, as you can see, this graph is going up fairly quickly. So the graph is going up fairly quickly. And the points that I'm mostly interested in here is the forward voltage and especially the forward current. So the forward current is going to be somewhere over here. It's going to be around 20 milliamps. And the forward current is a very special number. It's a number that you should never, ever go over if you don't want to burn your LED. This is the maximum amount of current that LED can handle without burning out. So you really should not exceed that number. But we also have another number that is almost as important. We have right here something called forward voltage. And forward voltage is the amount of voltage your LED must receive in order to light up. If it doesn't have that much, it's probably not going to light up, or it's not going to light up very well. Now, those numbers are not set in stone. I actually didn't have any data sheets for the LEDs that we have in class. So those are the ones that I think are the forward current and forward voltage. They're probably fairly accurate. So let me put down what forward current is. All right. So when you look at our graph, we always want to be in this region over here. Let's call this a little Goldilocks zone, right? We want to give it just enough voltage and not too much current. Now here's the thing. We have different color LEDs in our class, and different colors actually have slightly different graphs. Now the graphs will all have the same basic shape. However, though, that point of the forward voltage is going to be in a different place. So here's my yellow graph. Well, the forward current for the yellow is probably around 2 volts. Now the forward voltage. Now the forward current for it is probably still around 2 milliamps. Now what if I have a green? It's even further out. So this one is around 2.2 volts. Now I don't have any blues in this class, but if you decide to buy some and use them, their curve is really way out here. So the forward current over here is going to be around 3 volts. And the white ones are probably closer to 3.5. So this is really all you need to know about LEDs in terms of the curves.